Hi everybody. So today we're going to be working on this handout for graphing lines. I'm going to try to go quickly but clearly so you can follow along in your notes or just watch what you see here. Billy works at Wendy's. The table shows how much he gets paid based on the number of hours he works. Graph the relation. So we have a table of values here and we need to just follow along. Plot all the points. 5, 80. Notice that the y-axis is going by 40s. 10, 160, so that's going to bring me up to there. 15, 240. Now you can list all of these numbers on the y-axis. It takes a while. But the important thing is to realize you're going to get a line. And one of the values that's not on this chart, which I wanted you to think about, is that if you work 0 hours, you're going to get paid $0. It always follows this pattern in the scale that's going on there. The y is going up, the x is going up by 5s, and the y is going up by 80s. So this will bring me up to 400, and that will be 480. It's all predictable. We draw this with a straight line. Hopefully you're going to use your straight edge. Goes on forever. Now, this is what we call a direct variation. The main thing to remember is it's going through the origin, and it slants. Okay, it's not horizontal. We'll see that later. This happens to be a positive slope. How do you know it's a positive slope? It's slanting up and we're moving toward the right. When you want to calculate the rate of change, you can just take the jump in the x and the jump in the y, or you can look at the rise over run. Any pair here is going to work. This is going up by 80. This is going up by 5. And so that's going to be 80 over 5, which reduces to 16. The units on this are based on what we see in the example. The dollars is the y value, so it's going to be $16. And the x value is the number of hours worked. So that's going to be $16 per hour. That's going to be this person's rate of pay. Now, when it asks you to find the equation for this guy, it's just a matter of saying, well, it's y equals ax plus b, and the rate of change is the a. So it's going to be 16x, and the b is the y-intercept, right? And in this question, the x-intercept b is the origin, so it's 0. So I could write plus 0, but we usually won't write that. We put the minimum required. And so we can figure out how much this guy gets paid for 12 hours of work by replacing in x equals 12, right? X is the 12 is the x value, and you multiply, take out the calculator. 16 times 12 comes to $192. And how much does he get paid for 0 hours of work? Well, sadly, he gets paid nothing. Direct variation relation, it looks like this generally, going through the origin. Here's my x and my y axis. The next one is going to be another direct, this is going to be a partial variation relation. And the main thing to realize is that it's not going to be going through 0, 0. It's going to be going through 0, 60. So here's 20, here's 40, 60 would be about there, and that's an ordered pair. 5, 75 is going to take me to about there. 10 to 80, 1090, right? Let's be careful about the scale. The x's are going up by 5s this time, and the y is going up by 15. And so my scale is actually going by 10s, might get a little bit confusing. But as I say, the pattern is going to be there. You connect it with a line, and you're going to find out that it's a partial variation. So in terms of the table, these are going up by 5s, as I said. So this is going to be going up by the same amount of 15, 135, 150, 165, and 180. When you go for the rate of change, it's always the change in y over the change in x. Whoops, I wanted to put a 5 there. And you're going to do the 15 divided by the 5 for any of these pairs. 15 divided by 5, 15 divided by 5. For the rate of change, it comes out to 3. And just like before, what units do we get on that? Well, it's 3 pages, that's the y value. Whoops, pages, for every 1 minute of reading per minute. And this is actually talking about something that's not starting at 0. The slope of this guy is going to be positive, is because it's slanting up to the right. That's about all you need. Oh yeah, what is the rule? The rule is going to be y equals ax plus b, and the rate of change is the y, so that's going to be 3x plus, and the b, the y-intercept, is where it hits the y-axis, and in this case, the y-intercept is going to be 60, so it's 3x plus 60. It says use this rule to find what page she reaches after 42 minutes. Just like before, you plug in 42 for the x, right? Because that's how we read. Minutes is on the x-axis. And we're going to add 60 to that. So same deal, take out the calculator. And 3 times 42 plus 60. Now you don't have to worry about the order of operations. The calculator will take care of that for you. So not dollars, it's going to be 186 pages, or at least she's going to be on page 186. And what page is she on at 0 minutes? Well, oddly enough, that's what we just calculated. That's the initial value. So partial variation, what does that look like? Well, it's going like this, but this time it's not going through the origin. It's going somewhere on the y-axis crossing, and it's on a slant. It could also be slanting downward, as we're going to see in the next question. So these guys are traveling in a car, and they're traveling a distance of, let's say, 30 kilometers, and they're going to lose 5 liters of gas because it gets burnt up, right? That's how an engine operates. So we're going to be going down 5 each time that we go up 30 kilometers. So plotting this on the table, the scale's not that great, but let's go 10, 20, 30. Remember, I'm actually going by 5s, but I'm skipping every second one so that I can fit all these numbers on there. 80 would be up there somewhere. And where's 60, 80? Well, remember, this is the x scale here. 90, 120. And I'm not going to put all the numbers on there. So 60, 80 would be up there, a little bit off the graph. 90, 75 would be around here. 120, 75, 120, 70. 150, 65. And as you can see, same kind of pattern emerges, but I don't have to waste my time looking at the numbers in the table. These guys are still going up by constant or down by a constant. And I guess I should continue the chart on the X numbers also. It's going up by 30. So as you see, if they go 300 kilometers, they only have 40 liters left in the tank. It's a line. Use a straight edge. That's a pretty bad line, Mr. Powell. Let's try that again. Get rid of that. And there's an arrowhead there and an arrowhead there. And we can actually figure out y-intercept by counting that up to the top. I'm not going to spend time on that right now. I'm just going to look at the rate of change, which is -5. That's my y value, right? That's the dependent over the change in the x value, which is the independent. And this time it's a negative fraction. And if we try to get a decimal, it's going to be really ugly to work with. And as you see, most of the time when we're working with equations, the rate of change is going to be a fraction anyways. So the rule of the function would be y equals -1/6 x plus whatever that y-intercept is. Now, how do you find that out? Well, like I said, we can backtrack. So if this is 30, right, go back 30, this is going to be going up to 85. And if we go back one more to 0, this is going to be going up to 90. So the initial value for this is 90, which would be where it's crossing on the y-axis if I was drawing this accurately. More on that in grade 10 when you're trying to figure out the equation of the line. And it asks you to find the amount of gas after 132 kilometers. Well, just like before, we replace in the x, 132. And then add the 90. 132 divided by 6, right? That's how we multiply by 1/6. And that's -22 that we're going to add to 90 is 68. And what does that get us? Oh yeah, that's the amount of gas, liters. And how many liters at 0 kilometers? We did that a couple of seconds ago. That's our initial. Partial variation relation again, except that this time it's going on a downhill. And I forgot to mention that it is possible that your partial variation relation could go starting in the negatives, going down, or starting in the negatives and going up. All of those are acceptable. Okay, so I'm going to skip number 4 for now. It's another direct variation relation, but I'm going to jump to number 5, which is a very strange situation. It says the students going on a field trip are going to rent a bus, okay, that costs $800. And no matter how many students are on the bus, it's still going to cost $800 as long as they don't go over the capacity. So completing this table is easy enough. Same deal. I'm going to skip every second one for the labeling so it goes a little bit faster. And you don't really need all those numbers because no matter what, everything is going to be at 800. 0 passengers, 800. 5, 10, 15, 20. All of these possibilities are still going to cost $800 to rent that bus, provided they don't go over 54 passengers. And so this is what we call a zero variation. It doesn't vary at all. And what are the characteristics we need? Well, it's horizontal line. It doesn't go through the origin. The slope, it doesn't slope up, it doesn't slope down. The slope is equal to 0. Hence that zero variation. So when I go for the rate of change, not that you really need to, but if I try for the rate of change, this is going up by 0. This is going up by 0. And on the x, it's going up by 5s. And so your rate of change is 0 over 5, which, just to be sure, you do that in your calculator, 0 divided by 5, which is equal to 0. Units, $0 per student. What you could interpret this as saying the students aren't paying anything, but it just means that it doesn't cost any more money if there's more students. So the equation of this function is kind of weird. It's 0x plus b. In this case, b is the 800. Well, we're never going to write the equation this way. We're going to write it just as y equals 800. And so as long as the number of passengers is less than 54, the cost is $800. So that means the initial value is equal to 800. That is your b value, your y-intercept. So a constant function or a zero variation relation is a horizontal line. Okay, and it could be in the negatives also. Hopefully this helps understand a little bit about what's going on. There's a summary right here about all the details you need for the 3 types of relations and a couple of practice examples that you should be able to work out fairly quickly. I'm not going to have time in the video, but you can look at that later. It would be really helpful if you could record or put this stuff onto your memory aid. And when you're putting the 3 different types of variation, it's always good to put a picture. The direct looks like this. The partial looks like this or this. And the zero looks like this. All right, enjoy.